Okay, so just to recap here, we're finding probabilities by getting area under a curve. Instead of typing in the whole thing, we are going to use the normal PDF, okay? So where are we going to find this? Well, first of all, on your calculator, hit your y equals, and we're not going to punch in a whole formula, but this normal PDF function is found under distributions. DISTR is above the vars, the variables button. So we're going to hit second, variables, and you'll see normal PDF and normal CDF. We're going to use the normal CDF, and we'll actually use inverse normal later on this week, okay? But we're going to use normal PDF today. So we just hit enter on this, and I'm going to type in the variable x, followed by a comma, and then you put in the mean, which ours has a mean of 5 and a standard deviation of 1, okay? Now, before we actually hit graph, let's think about what our window is going to look like, okay? I mentioned already that when you're going to graph these, our y is never going to go above what? 1, okay? So, for my window, I'm going to make the y go from 0 to 1, okay? Also, the x's, think about this in terms of what we were learning on Monday. If our mean is 5 and a standard deviation is 1, and we want to make sure we get, obviously we're not going to go negative infinity to positive infinity, but we want to get a good amount of our data in there, okay? If I went from 0 to 10, how many standard deviations would that include on either side of my mean? 5. Okay, so is that going to give me most of my data? Yeah, okay. We saw that even after 3 standard deviations, we've only got an extra 0.25% on either end. So if we go to 5, we'll definitely get a good picture. So we're going to go from 0 to 10, and now hit graph, and you'll be able to see your bell curve here. Okay? So that's a really nice way to graph it. It sure beats trying to type all of this in correctly, right? So, yes, David?
How do you use the normal PDF and then put it in the stat column?
You just hit enter on that, and the x value. Oh wait, hang on. Do it in y equals.
Oh.
Now hit distribution normal PDF. Yeah. And then just type in x, and mu is going to be 5 and sigma is 1. And just hit enter. There you go. All right, so now you should have a graph, okay? And we set the window there, and just so we can take a look at it here. All right, here's our graph. Now, what we're going to do is we want to find the probability, and this is really what the focus of our lesson is going to be on today, now that we know how to graph it. We're going to find the probability that some random variable x is between 2 values, okay? Or we could also say x is greater than something or x is less than something. You know, there's all those variations. But let's see, if we have a mean of 5 and a standard deviation of 1, let's say that we want to figure out the probability that a random variable x will fall between 3.5, that's going to be 1.5 standard deviations down, which we weren't able to do on Monday, okay? And let's say 6. All right, so how would we do that with our calculator? Right? Here's where the integral comes into play. And I'm showing you this. There is another way we can do this that may be a little easier. But either way, it'll work. So what we're doing is we have 1, 2, 3.5. So right here, over to 6. So there's 4, 5, 6. Right? And basically what we want to get is the area under this curve. Okay? And if we can find that area, that will give us the probability. Alright? So I come back over here to my calculator, and we're going to calculate an integral. Alright? You might say, well, I have no idea what integrals are yet. That's okay. All you need to know right now is that an integral will give us the area under the curve. Okay? So, you'll see calc above trace. We're going to hit second calc. And you'll notice down here, number 7 is the integral of f of x dx. Alright? And now look at what it's asking us for. It's asking us for a lower limit. And the nice thing about this is you don't have to scroll. You can just type it in. 3.5 is our lower limit. So we hit enter. And then our upper limit is going to be 6. And again, you can just type it in. And it even shades it in for you and tells you that the area is 0.7745. Yes.
So we hit second calc and then
Second calc and then number 7, you'll see the integral symbol. Okay? Alright, so this is what we end up getting, and notice the area right here, that's our probability. 77.5%. Okay? So picking a random piece of data out of all of our normal distribution, we've got a 77.5% chance it's going to lie in this interval from 3.5 to 6. Okay? Does that make sense?
Yeah.
So it's a nice function. Okay? And this, you should be able to sketch something like this, a rough sketch of what you're doing when you're finding a probability. Okay? Alright, so is there a way to do it without actually having to graph it and play with the window? Okay? Because where this can get not complicated, because it's not really complicated, it's just annoying, is let's say our mean was over at 78 with a standard deviation of, 0.5. Well, then you're going to have to make your X window go from like 75 to 81 or something like that. And rather than play around with your window, we can use another function that'll do it without having to graph. Okay, without having to actually see the graph. Okay, and that is, here we go, that is our normal CDF. Okay, our normal CDF. Now what this is a normal cumulative density function. Okay, it's a normal cumulative density function. And what this does is, rather than using the normal PDF and plugging in the mean and standard deviation, graphing it first, then getting the integral and when you do that, you have to provide a lower bound and upper bound. Now you can do it all in one step. Alright? Now, you don't do this from the y equals menu, from the function menu. You go back to the home screen where you're just calculating things. And you go back to second distribution. Choose that normal CDF. And we can do the same problem we just did by typing in 3.5, comma, 6, comma, 5, comma, 1. Okay? Our lower bound was 3.5, our upper bound was 6, our mean was 5, and our standard deviation is 1. Okay? So, to see that working here, this is what you should be doing. If you go back to your home screen, again, under distribution, second distribution, we're going to use normal CDF this time, number 2. And then we just type in those values, 3.5, 6, 5, and 1. And it'll give us the 77.5% again. Okay? Alright? So, a lot of this, guys, is not really difficult as far as getting the numbers you want. The challenge here is understanding the situation, what to punch into your calculator, and how to interpret what comes out of your calculator. Okay? That's going to be the real challenge to these. Okay? Alright, so I want to practice a little bit. I posted homework on Skyward on the Sunday Post, but we're going to actually do a good bit of that here in class today. I wanted to start with number 2 here. We've got a x is a random variable distributed normally with a mean 60 and a standard deviation 5. And before we even get into this, let's take a look real quick. And just to review a little bit of what we did on Monday. If I were writing this in notation, or if I were given this with different notation, I might see this. What would follow that? N?
Parentheses, 60, 5.
Okay. You guys agree with that? What goes in our parentheses?
The upper and lower.
Upper.
No, not for this. X is distributed normally with a mean of 60 and a, this is where it's variance, okay? Remember, the variance is what goes in here, and that's easy to forget. That's why I wanted to review this. You're going to see this, okay? Or if they're really being nice to you, you might see it written as 5 squared. Sometimes you'll see that, and that's just them kind of reminding you that this is the variance and not the standard deviation. Yes?
So that 25 comes from the standard deviation squared?
Yes. Remember, variance is standard deviation squared.
Okay.
X is distributed normally with a given mean and variance. Okay? Now, another thing that you should be able to do is visualize what exactly you're finding. Alright, so for part A, we want the probability that X is between 60 and 65. So if we draw our bell curve, we're going to put our mean right here at 60, okay? And then we want to go from 60 to 65. Well, 65 is exactly 1 standard deviation above, right? So we're finding this area. Now, if that's 1 standard deviation above the mean, what percentage is that? We actually did that Monday.
34.
Yeah, that's 34%. Okay? So 34%. Now, you can do it with your normal CDF on the calculator as well. Okay? If you don't remember it, that's a nice thing. You can always punch it in there, but this is a way of saving time. If you recognize, hey, that's 1 standard deviation, I know that. Yes?
So it will always be 34% for any value.
From the mean to 1 standard deviation above, yes.
Okay.
Mm-hmm.
What about below?
And below, yeah. Because remember, within 1 standard deviation was 68% of our data.
Okay.
So half of that, you got 34 on each side. Okay. And then we saw it was 13.5, and then 2 1/4, and then that last 1/4% on the outside, past 3 standard deviations. If you know those, that can help. So take a couple minutes here and just find each of these probabilities. Notice some are greater than or equal to. Some of them are less than or equal to. And see what you would do to get those different values. Okay. Joel, we're using our calculators now. You cuddle down with somebody who has the same kind that you do.
That's just minimal.
Yeah, I know it, but there's a place in which
I had 64 times.
about 70. Okay, so I was in your regular distribution. That's the new normal distribution. So it's like X from the standard deviation
What is
out is
less than like that?
One standard deviation.
Yeah, but
I don't see it in this
yeah,
problem,
but if you go
but when it doesn't have the equal to sign, you just
3
go
standard
highest
deviations
decimal.
out, it's
It
like
actually-
90.
Yeah, that's a good question. What do we do if it just said greater than or just less than? Remember we said on Monday that individual values have a probability of 0, right? So having it greater than 64 or greater than or equal to 64 will make no difference at all.
It has a probability of 0.
Yes, at 64. Because this is a continuous distribution, the likelihood of getting exactly 64 is basically impossible because no matter how precise you measure, at some point you're rounding, so that's just theoretically what it is.
But it's not.
So you
Is
can't
it-
even put
Is it actually impossible?
Well, here's the thing, I mean, we don't know if it's possible because whatever this is, if we're measuring a length of something, if you're using a ruler, it only measures down to like the 1/10 of a centimeter, right?
Yeah.
So how do you know if it's exactly, or if there's like a couple
Zero,
microns
zero,
one
zero,
way?
zero, 1.
Yeah, I mean it could be that. So that's just why we do it this way.
No, you do not need to do it with the graph. Do not do it.
If he likes using the graph, he's welcome to use the graph.
Okay, so
Okay.
you go second, then all the way down to number 7, integration, click on it, and then the lower is which one you got.
For letter C, So if it just says
That's
x
zero.
greater than
If it's one number equals 64,
Oh, wait.
That'd be the upper bound.
The upper bound, you would just need to make sure that you've got a big enough number to include enough of the
probability of
So,
getting exactly
you could,
64.
well, you can do it kind of thinking about the standard deviation.
Not impossible.
Okay, alright, 4 or 5 standard deviations is gonna
It
be
really is
12.
impossible.
So that's
Cannot measure
20
exactly
plus
64.
5, so you're talking going up to 80 or 85.
This is what
You
you
can't measure it.
Or you could just put in
But that's not a
90 or
continuous, that's
95.
discrete.
Yeah,
it's not random.
yeah, just
Yeah,
pick
it's
a real big number and you'll get it.
Okay, if you had a continuous, say you had a length of something, you could not measure it to exactly 64 of anything. You can't do it.
You could.
You can't. Eventually, maybe, but not right now. So that's why this is the way.
But not right now.
Are we not using one?
Jay, you just gotta have faith.
I don't want
You can do it to the
Jay, you
exact.
just gotta have
I
faith.
think deep up to look at the exact.
Is that anyone can do it normal too?
Yeah, if I could do it, it's
Okay.
So then.
because I have faith.
Yesterday, your mom gave me
But what's our highest grade?
Wait, Jay's not gonna do it?
How much? He was like, no.
Yeah.
It was one.
Yeah, the IB basically they have you doing all this stuff on the
Wait, Jay,
calculator.
did your old mom
So they're not gonna give you
Yeah.
this.
Can't even enter
Yeah,
the year.
zero.
Yeah. There are other ways of doing
Mr. Parsons,
stuff,
Jay,
but
any information?
it's just a matter of
Josie's
picking one.
There's like only one.
No, I'm saying, Jay,
everything else is around. So it's like it's the
Okay. Yeah, well, like here, 64 is your lower bound. So basically, you just need to pick a big number
for Brown this year.
and like make sure that it's going to include basically everything.
Does the alumni interviews?
Can Mr. Parsons?
Oh.
Yes.
The reason is, and this is where using the graph
It's only happened one
is
time.
difficult.
When you're over some
Your window right now only goes up to 10. So that's where using the normal CDF on the home screen is going to be better because you don't have to mess around with your window. Yeah. Alrighty guys, let's take a look here. You've had a chance to work through at least most of these by now. So the first one we already said was 34%. Remember, this is what we're using, normal CDF. If you want to use the graph, you can, but this is one of those ones where I was telling you it's kind of a pain because you got to think through the window settings. Alright, because you cannot find the integral if the range you want is not in the window, in view. Okay? So if I were doing this with the graph, I would have to think, okay, if my mean is 60, standard deviation is 5, 60 minus 4 standard deviations would take me down to 40, plus 4 standard deviations would take me up to 80. So I would need to make my window, you know, from like x equals 40 to 80. And then y would still just be 0 to 1. But using this, you don't even have to worry about your window at all. Okay? So for part A, we would punch in the 60, that's the lower bound. The 65, that's the upper bound. The mean of 60 and the standard deviation of 5. And you'd get 34%. Okay? So what would you punch in on part B?
You would have normal CDF 62, 67, 65.
Yeah. Okay. Normal CDF. And I don't know why. Is it norm CDF or normal CDF?
Normal.
Normal. Sorry.
Wait, what?
Let me fix that. Okay. Okay. So we're doing normal CDF. And notice the last two numbers are going to be the same for all of these because your mean and your standard deviation aren't changing. Okay? Now, folks had questions about C. We have a lower bound at 64. Our upper bound, we want it to go to infinity, but obviously we can't punch in infinity. So this is where understanding your normal curve is helpful. Once we got past 3 standard deviations, remember there was only 0.25% left, right? So as long as we pick a big number for our upper bound, we're going to get it, since we're rounding to 0.1%, we're going to get it accurate enough just by picking a big number. So you could do it and think in terms of your standard deviations and go up like 5 or 6 standard deviations.
Like 100.
Or yeah, you could just throw in a bigger number like 100. Or I picked 85 because 85 would take me up 5 standard deviations. Or you could just punch in 99999. Okay? It really doesn't matter. No matter what you pick for this, as long as it's at least 4 or 5 standard deviations up there, you're going to get 21.2 when you round to the 0.1%. Okay? Alright, so that's C. On D, we want the probability that our variable is less than 68%, or less than 68.
When you use 68 and like 0.
Okay, yeah, we could pick 0 for our lower bound. 68's our upper bound this time. 60 and 5. Okay? And you're going to get 94.5%. One warning I will give with the lower bound is just a lot of times you can pick 0. Alright? For example, even on the previous example here, our mean was 5, standard deviation is 1, so if we pick 0, that's 5 standard deviations down. Where you have to be careful is if you're dealing with values that could be positive or negative.
And you like deep negative.
Yeah, 0 might only be like 1 standard deviation away from your mean. Okay? So don't just always pick 0. Make sure that you keep in mind your standard deviation, your mean, and maybe put in negative 100 or something like that, just to make sure. Right? That's D. E is similar. It's just from 0 to 61. You should have gotten 57.9%. And F was 38.3%. Okay? Does anyone have any questions about any of those?
For C, why did you pick 85 as the upper bound?
I did it because with a mean of 60, standard deviation of 5, that's a difference of 25, right? So that's 5 standard deviations up, which is enough. Okay? But all right. We're going to do a couple of the word problems from the homework. Yesterday, the first period class, we did 5, 6, and 7. So in your homework for your own practice, you could practice 5, 6, and 7 and take a look at the notes online and you'll see the answers. Alright, so you can double check yourself. We're going to go ahead and do 8, not number 8, number 6, 7, and 8. And then we'll have all the answers up there that folks can check on the notes online. Okay? So let's take a look at number 6. It says the speed of cars passing the supermarket is normally distributed with a mean of 56.3 kilometers per hour and a standard deviation of 7.4 kilometers per hour. Okay? I don't know why they made kilometers per hour look like this, but it really doesn't matter. Okay? The mean is 56.3, standard deviation is 7.4. So what we've got here is we have x being distributed normally with a mean of 56.3 and a variance of 7.4 squared. Okay? So, we have A, B, and C. And what I want you guys to do actually, we've got, well now we have 13, right? 4, 4, 4, 2, we have 14. So I'm going to have you guys go ahead and get in, we can do 2 groups of 4 and 2 groups of 3 to kind of divvy it up evenly. And go ahead and move your desks together. I want you guys to work together on these. And then I'm going to randomly call on somebody to provide your group's answer. Okay? So go ahead and move your desks together. And I'm going to give you a couple of minutes here to do this. Guys, I want everybody in a group. So move your desks now, please.
Okay, so.
I'm done.
We don't need a group of 5. One of you 5 needs to go through another group here.
It's gonna have to be
I already got it.
I already done it.
Yeah. So.
The first one? Yeah.
Oh, you guys are still number 1.
You guys are group 1. You'll be 1, 2. You guys are group 1. David, why don't you let me get these guys over here? So
B is at most 70.
you guys are group 2. Okay. You have your own calculator?
Yeah, Jane.
Oh, do you? It's okay.
Oh, that's.
B is at 96.
Did I
You
get
guys
it
are
right?
group 2, and your person is group 3.
Yeah, let me see.
What'd you get? Sorry?
When I'm right, I'm right.
Sorry.
Yeah, when I'm right, I'm right.
You're number 6.
The
You're number 1.
Just put 7.4 square.
What'd you guys get?
I mean 7.4. You guys like calculator? I was
Yeah, I have some.
It's just 7.4. Like 7.4 squares is very. Doesn't matter.
And then what'd you consider that for about?
Let's see. If you're at 56 and your standard deviation is 7,
So you is right there, dude. 7.4.
like 5 standard deviations, so that should be good.
Yep.
Just don't always put a list over something. Alright, so your team 4, you're number 1. You're number 2. Amy, you're number 3. Your teammate number 1, 2, and 3 of team 4. That's how we're going to pick random people.
I'm done.
I'm done.
Finished. It is finished.
30.3.
Yeah, I did.
Monday.
Wait, how many? Which question? Are we just doing 6? Are we just doing 6?
Just do 6 for right now.
We're just doing 6 right now. We can call it so we don't have to do 7 yet.
One for the grams, so the low portion will be 114 times.
So I did the thing, right? Andre, high school, professional, and then
Alright, do we have answers? Do we have results?
we do.
Okay, so our first person to share is going to be Team 4 player number 2. Okay? That's what the calculator, that's what the computer picked. So for part A, what did we, who's 4-2?
Okay.
Mary, okay?
30%.
30%? Okay, so you put in for your normal CDF,
Going backwards.
Everyone else should be silent, please.
56.3
Yes.
and 7.4.
Alright, so move that down. Okay, so good. And then you said you got 30 point what?
And the result was 30%.
30%. Okay. Alright, does everyone agree with that? Yes.
How many decimal points do you want us to?
What I would want you to do when you're giving percentages is go ahead and round to the 10th of a percent. Okay? That'll give us, normally our three significant figures.
30.9.
So what was it? 30.9?
No, 30.27.
Oh, 0.3, yeah.
30.27, so 30.3, we should go ahead and give one decimal point, just for accuracy's sake. Okay? Alright, so let's see, part B, we'll recalculate. Alright, team 3, player 1, where are we at? Alright, Laura, for part B?
It's 96.79%.
You got 96.7?
Yeah, 0.8.
Yeah.
Okay, so 96.8%. Alright, and in here, we know the last two numbers are the same. What did you do for the first two numbers?
0 and 70.
Okay, 0 and 70. And that works because, think about your standard deviation is 7. So if you put it at 0, that's almost 7 standard deviations down, right? So that's plenty. Okay? So.
Also, a car can go negative, right? I guess it's backwards.
Well, yeah. Yeah. Now, interpreting your answer, you would want to take that into account. Doing it theoretically, you would want to still make sure, don't just always put in 0, but yeah. Alright, good. So then for part C, team 1, player 1. Jay?
30.9.
30.9?
It's shaky, bro.
Okay. And what'd you put in your normal CDF?
It would 60,
Okay.
85,
Alright, you did 85.
and 26.37. You could go any number.
Okay. And if you look at that, guys, that's 25 above your mean. With a standard deviation of 7.4, that's more than 3 standard deviations away. That's decent, so that'll be fine. Okay. You could obviously pick an even bigger number, but okay. All right, good. So there's number 6. Any questions? All right. Let's move on to number 7. Apples from a grower's crop were normally distributed with a mean of 173 grams and standard deviation 34 grams. Apples weighing less than 130 grams were too small to sell. Okay? So, part A, find the proportion which were too small to sell. Find the probability that a picker's basket of 100 apples, up to 10 apples, were too small to sell. Okay. Alright, so go ahead and work with your team to solve those.
I have a question. Which I just supposed to be the low
Is
bound,
that-
be 130 because smaller than 130.
Probability?
And the
So
upper
it's
I just
off.
put 200, just big bend that go down. And when I entered that, I got 68.3.
What did you get?
So, what I'm doing is, so the lower bound would be 130.
because
Yeah.
it's small.
So the lower bound would be
Just make it
130
too big number.
because anything less than 130 you can sell. And then just pick.
Yeah, so we
A
did
big
the
number than
1,000.
the standard deviation and mean and
And then
0,
Mean is
130,
standard deviation.
34.
173.
So what'd you get?
68.3%.
It's 68.
And like,
We
Got 89.
We got 89.
Yeah.
Yeah, but we
for that.
and then for
Oh, shit.
Oh,
Go with
you,
89.
your sounds too high. It's too low. It's not that.
What?
Went down.
Yeah, but it doesn't matter.
It shouldn't matter.
Okay. Let me try. Maybe mine was a bit low.
We're like a billion instead
Oh,
of
fine.
Oh, because remember the standard deviation is 34. So you gotta
Yeah.
multiply that by,
Oh wow. Okay, so I think my standard deviation was a bit low. Let me try that again.
Okay.
He's
Probability
like
that
500.
10
then
outcomes.
your actual
80.7%.
Yeah, I got 89.
Okay.
So 89.7.
No, we found.
Wait, what did you get?
Yeah.
Well, the proportion is 89.
Let's just use a bigger number because it's way too small.
So it figures back to scale of 100 up to 30. So that would be 0.
Lower bound upper bound of 10.
Yes. And that would be the lower bound of 0.
Lower bound. Well, not 0 because
Then around 90 of the apples
the
would
standard
be
deviation is 34.
I'm not sure how
How many would that be?
I got A.
So just pick a really small number.
So negative.
He's a challenge.
Why not?
So find the, okay, so if you take find the probability in a Peters basket of 100
Do you know how
Well,
far the
10
number
It's
the
something.
probability?
So-
Red.
I'm just not sure how to get that number.
Oh, yeah.
Yeah.
apples and the
Do you want to hear that? Let's try it.
average.
I'm just gonna try 0.
No.
Because we don't know how far to be.
Part B is kind of just an extension, it's a challenge.
And we did it. Oh, yeah,
So for part A, this is, we're looking for the percent. Like,
Did you put the upper bound as 10?
Yes, part A is just percentage.
and then part B
Still
was
second
like,
grade.
like,
Is that the way?
Huh?
What is
My writing's
That's A,
I got 640.
and then what's the probability?
So it says find the percentage that if you choose 10 apples, what is the probability that if you
So
choose
you're
100
thinking
apples,
correctly.
10?
That's the thing, you gotta wade through things that don't matter and really get to what are they really
So
asking.
upper bound would be 10.
yeah.
We both
That's what he said.
Yeah,
Maximum
because it's up to 10,
Well,
it's
it's
maximum
kind
of
of
10.
hard to-
And then, but then the minimum would be 0 if you get a negative apples, but
we
I-
find
I guess
I-
you would have to make it
Take a
as a
Two
standard
small
deviation,
cells.
but
deviation
It's
down,
one
and
ten
then
divided
we'll
by
know that
100 because
from the average,
you're looking
that's,
at 10 out of
that's 34 grams less than the average.
oh,
And
probability
keep
of
going,
10.
and then you
Yeah.
find that,
10%.
and then you, so
What do
say
you
it was
do?
2.4 grams.
On black, it's like,
B
And
says, okay,
that
so I know the probability of
2.4% of any given product is gonna be less than the cell
So
weight.
that is the probability of apples
So,
compared to
you
if you
look
count
at
in the
2.4%
proportion of
of
A,
is
that's
2.4.
basically
And
impossible.
I think it's
Because
just
the
trying
proportion
that
of
would
A
be
is 90% apples.
apples.
So 90 out of 100 would need to be too small, so I'm not sure what's
Oh, no, I got it.
it's like a
Yeah, I don't know.
one.
Because this is 10.2.
But B is
just hope it doesn't fall
impossible.
Alright, let's take a look at part A, okay?
It seems like it's a trick question.
Where's it? Team 3, player 1. Oh, you already went. Let's get someone else. Team 3, player 4 doesn't exist. Team 2, player 4?
I think that's me.
Alright, Amanda, what do we do for A?
So,
Okay, so for the lower bound, it had to be 130 because upper bound had to be 2.
Wait, guys, be quiet, please.
So the lower bound was 130,
Okay,
and then for the upper bound, I chose like 400 because I don't know.
okay,
And then the mean was 173, and the standard deviation was 34.
okay.
So I got 89.7%.
Okay. So we're using that normal CDF. Okay. Now, we can get our answer this way, but this actually isn't answering the question. Find the proportion from this crop which were too small to sell. We want the ones that are less than 130 grams. You found the percent that was...
130 would be the upper?
No.
Well,
Yeah.
you could do it one of two ways. You can use this answer because you just found the percent that are
10.3.
okay to sell.
So you just subtract it from 100.
To
Yeah.
100.
And guys, that's good. If you recognize you found the wrong side, just subtract from 100. Don't redo the whole problem. Okay? So, 100% minus that, that means 10.3% are too small. Okay? Now, what others of you probably did is you paid 130 your upper bound, and 0 would work in this case. Well, actually, if you think about it, 0 from 173 with a standard deviation of 34, that's about 6 standard deviations almost. So that's still low enough for us. So that'll give us 10.3. All right. Now part B is kind of strange to think about. All right. If you're getting 10 out of 100 that can't be sold, what percent is that? It's 10%, right?
Yeah.
All right, which is actually what we found it should be, right? So find the probability that in their basket this happens. Okay. Well, that's
going to happen.
it's basically what we're expecting to happen. So the likelihood of that happening
It's very high.
is,
97.
we're going to get, each one is 10.3, okay? So basically B, it's going to happen. The other way of thinking of it is, what's the probability that all 100 are large enough? Okay, we have this percent chance that each one can be sold, right? And this is actually getting into probability stuff we haven't covered yet officially, but if that many can be sold, and we're doing that 100 times, okay, what's the probability that all of them will actually be okay?
How do you calculate that?
Well, you actually would do it just by taking that 0.897 and you're doing it 100 times, so to the 100th power. Why isn't this working? For some reason, anytime I minimize it, it dies on me here. Alright, so 0.897 to the 100th power. The likelihood of getting 100 apples and none of them being too small to sell would be 0.000019. Okay, so almost impossible. All right. And also notice it said up to 10 apples, so we could just get 1 apple, or 2, or 3, or 4, or all 10 out of the 100. Okay. So the likelihood is really it's almost 100% chance of having, really what this is asking is having at least 1.
At least 1?
Yeah, because it said
to
up
10.
to.
Yeah.
Alright. Okay. So. Alright. Anyways, again, that part of it kind of went beyond what we've done so far, but That's okay to challenge yourself. All right, our last one we'll look at number 8. This is an interesting one from a medical standpoint. Here we have this medication, and we're seeing its effect on patients. Okay, so here's people with high blood pressure. Notice we can't just compare their blood pressures, because somebody might have a high blood pressure that's like, I don't know, 190, and someone else might have high blood pressure that's like 220. Okay? But we want to look at the effect of the drug. How much is it bringing it down, not necessarily what does their blood pressure end up being. Does that make sense? It's kind of maybe something that might make more sense is if we were talking about weight loss, we couldn't just compare everybody's weights because everyone's a different height and everything. Okay, you would have to consider how much are they actually losing, not what weight do they end up being at. So that's kind of what we're looking at here with blood pressure. So it says the tablets, they have their blood pressure checked at the end of 4 weeks. The drop in blood pressure over the period is normally distributed with a mean of 5.9 and a standard deviation of 1.9. Okay, so on average, these people, their blood pressure dropped almost 6 units. Okay, so it says find the proportion of people who show a drop of more than 4 units. Okay, and then B, 8 people from the large population are selected at random. Find the probability that more than 5 of them will show a drop in blood pressure of more than 4 units. This one, again, is kind of going beyond what we've done. Take a look at A here. How would we find A? Okay, so we're going to do 4 and then
I just press 9
9. Okay. If we're at 6, standard deviation of 2, 9 is only going to take us 2.5 standard deviations. So maybe do, yeah, something a little bit bigger than 9. You know, you could do, what?
Press 9 a bunch.
Oh, 9 a bunch. Okay, yeah, you could do that. That works. Okay. And then 5.9 and 1.9. And what do we get? 84.1%. Okay. So here's the thing, guys. If we wanted to have at least that much improvement, then our success rate is 84%. Okay. So that's where, you know, maybe if we were developing this and the 4 was the minimum that we wanted somebody to improve, maybe we have to go back and reformulate or add something else in here, because 84% success rate when you're talking about medication, I don't know if that's good or not, but that's where they could use this data to then try to figure out, hey, what if, you know, how could we do this a little bit better or get this number a little higher? Okay. All right. I think that's it. Okay.